Now we have the presentation from Roberto Torrent. Roberto, do you like any help for the presentation, or can you do by yourself? And also introduce yourself.
I will try. I'm at an airport, so the problem will be announcements. But let's be optimistic that there will not be many during my presentation. The objective of presentation is to propose a definition of a durability indicator that would be a contribution for discussion within the committee. Also, to establish some rules to be fulfilled by durability indicators, particularly where they are considered as performance indicators. And then I will show the example of the Swiss standard that somehow by chance comply with these rules that I mentioned in point 2. I will jump this first slide because we all know that each structure is running its own durability tests live during its service life. And there are many factors that affect the performance of the structure. So the conclusion we can, I think, all agree is that there is unlikely or impossible to get a durability test that sort of condense all these factors. But we know also that for degradation processes that depend on the penetration of aggressive agents like CO2, chlorides, and sulfate ions, etc., that have to penetrate through the surface layers of the concrete, it is generally accepted that tests that measure the penetrability of those layers are suitable as durability indicators for these particular mechanisms. And that we know that there are many tests that have been standardized, particularly those measuring permeability, water sorptivity, water penetration under pressure, gas permeability, and diffusion or migration, like chloride diffusion, chloride migration, electrical resistivity, gas diffusion, or carbonation rate, which includes also not only the diffusion, but also chemical reactions. Now, I will try to advance, of course, this has to be discussed deeply in the group, a definition of a durability indicator, thinking of these particular mechanisms. We can say that the durability indicators are characteristics of the concrete structure, like the cover thickness, or of materials properties of the concrete properties that are essential to or bear a significant role in the service life of a structure under its specific exposure conditions. And incidentally, this definition was coined during a meeting. I think Jost was present. I don't know, Carmen, if you were there. It was a meeting in Leipzig that was organized by Professor Den and Professor Boyshausen, actually on a similar topic. Okay, now to go a bit deeper. Sorry, I cannot now. Yeah. Okay. We can say also that durability indicators should first be meaningful. That is, that it should be closely connected with the relevant physical, chemical, and/or electrochemical deterioration mechanisms that govern the performance of the structure. Second, they must be measurably, preferably in a reasonably short time, through well-defined, standardized methods of test or analysis. And third, it should allow conformity assessment with specified requirements based on tests conducted at suitable, well-defined sampling points. That it could be the production plant, the delivery point of the concrete, the placement point, in situ on the finished structure, or in service if some years have passed since the structure was built. And preferably be linked to some modeling directly or indirectly via robust correlations with other properties. Now, I want to refer to a document which I find interesting for our work, which is a report on performance-based requirements for concrete. You know the authors, some names we know well, that provide some definitions that I took only a few. One is operating characteristic curve, which is a graphical representation of an acceptance plan showing the probability of acceptance of a lot versus the quality level of the lot. Then definition of a lot is a definite quantity of a product or materials accumulated under conditions that are considered uniform for sampling purposes. Penetrability, I used it before in the definition proposes a general term related to the ease of fluid penetration into concrete, which may occur by permeation, absorption, and diffusion. And finally, I cannot read my own slide here. A test performance, well, you can read it. I can't actually, because there's some well, but it's basically a test that measures a basic characteristic that is related to the on-site performance of the structure. Now, this same document proposes a list of requirements for a durability indicator to be suitable as a performance indicator. That is suitable for performance specification and acceptance criteria. And according to them, it should include first, the quality characteristics to be used as the basis for acceptance. What are we measuring? What are we on which characteristic we are based our acceptance procedure, and the specified value of the characteristic. Second, a sampling plan to use to obtain representative samples from the lot to be evaluated. Third, a standard procedure for preparing and conditioning the test specimens, a standardized procedure for measuring the relevant properties or characteristics, the criteria that will be used to evaluate whether the test results indicate an acceptable level of performance, including statistical methods, and finally, if applicable, some provisions to pay adjustments and actions to be taken in case of non-compliance. And now I will show the Swiss standard, which, and I will compare all these requirements with the provisions of in this standard, which you probably have heard from me several times. It is the Swiss standard called Concrete Structures Supplementary Specification. This is a French version. And this standard describes test methods applicable in Switzerland, not included in the European standards yet. For example, we have the Annex A describes the water activity test. Annex B, the migration test for chlorides, that is Annex E, the permeability to air on the structures, and Annex I, accelerated carbonation. Now, the test in Annex B and Annex I will be probably removed soon from this standard, and because are now included in the European standards. So we will talk about this air permeability on the structures. And so I will, in italics, I copy the requirements of the ACI document and how this is dealt with in this Swiss standard. So First, the quality characteristic to be used as the basis for acceptance and the specified value of that characteristic. Well, the quality characteristic chosen is the coefficient of air permeability measured non-destructively on the end product, or, in situ, or the air permeability on the structures. I here bring also a part of the definition of the durability indicator that I showed before, that I propose that this indicator should be meaningful, that is as closely connected as possible to the mechanisms of deterioration. And then the question is air permeability a meaningful indicator according to this definition? Well, we have shown that this air permeability is well correlated with the water penetration under pressure. It's also well correlated with the chloride migration of the new European standard. It also reasonably well correlated to the Coulomb test, the ASTM C1202. I have to mention that all these data are collected from the literature, except the red dots that were measured not long ago in Dubai. I measured their permeability, and later the other party measured the chloride, the Coulomb test, very low permeability concretes, very appropriate for this region. And finally, a relation with the natural carbonation. Here there are some values in which I participated, which are the circles. The rest are from other sources. This in the ordinates is the carbonation rate. There were different temperatures and moisture conditions of the different laboratories involved. And then it says that the AACA document that the specified values should be introduced. And this, in the Swiss standard, it is indicated in the last row of this table, which as function of the exposure, the aggressiveness of the exposure, as from left to right. So if you have XC mild carbonation, you don't need to measure it. But if you have, let's say, severe carbonation or mild chlorides or frost, then you get the value of 2. And if you have more severe chlorides or frost, the value is 0.5, 10 to the minus 16 meters squared. So you saw that this is in compliance. Now the sampling plan to be used to obtain representative samples from the lot to be evaluated. Now, the Swiss standard indicates that elements made with the same concrete type, which are also built under nominally similar conditions of placement and compaction, like, for example, you separate columns from slabs or from beams, and then within each group, you list the elements chronologically. And a surface, a lot, is defined as 500 meters squared, or 3 concreting days, which is less, as to define a lot. And then you perform 6 measurements on within each lot at random locations, with some limitations with the distance between the tests, of course, to avoid interference. So this is also in compliance. Now, a standardized procedure for preparing contains the test specimens. In this case, as we are talking about the C2 test, there is no way of conditioning, or has not been found yet. So we have the age of testing is defined. The temperature of the concrete and the air should not be less than 5 degrees. The moisture, very important for this test, measured by a contact impedance tester, which has to comply with the ASTM standard, less than 5.5%. Here you can see some of these instruments. Vicinity of rebars. If you measure in coincidence rebars, the cover thickness should be at least 20 millimeters to avoid that it affects the flow of air. And finally, if the surface is too rough, you have to polish it. So this could be this preparing and conditioning the test specimens. Then a standard procedure for measuring the relevant properties. Well, this test method is described in detail how you run the test in the standard. So this is also in compliance. Then the criteria that will be used to evaluate whether the test results indicate an acceptable level of performance, including statistical methods. Well, the condition of the Swiss standard is that from the 6 tests you made on a lot, not more than one should exceed the specified value. But there's a second condition. If you have just 2 tests that exceed the specified value, now you can select another 6 points at random from the same lot. And from this new series, again, not more than one test should exceed the specified value. And well, if these conditions are not met, then the lot is considered not in compliance with the specified value of permeability. I don't want to go into details, but of course, we have here the statistical methods, how you can calculate the probability of acceptance of a lot with a certain proportion of defectives, and you have to use the binomial distribution. I will not go into detail, but the result is the operating characteristic curve, which is shown in this picture. And you can see that the red line, the dotted line is condition 1. The red line is condition 2, of course, because you are giving another chance of acceptance. You see that the curve is above the previous one. And what is telling this chart as an example is that if you have 10% of the surface of your lot with a permeability which is higher than the specified value, the chance that you accept this lot applying the compliance criterion is 97%. And if 50% of the lot is defective, let's say has a permeability higher than the specified value, the probability of accepting such a lot is only 13%. So this looks reasonable. So now I will conclude. Well, in this presentation, a definition of the read indicator has been proposed. Of course, it can be improved, and this could be part of the work of this task group. Requirements to be fulfilled by durability indicators based on those proposed in this ASCI document are what is mentioned, and basically you have to select a meaningful characteristic for durability. As I said, could be cover thickness. This is also an indicator, in my opinion, or air permeability, as the case I showed before. Then you have to specify limiting values for the characteristic that should be a function of the exposure. You have to define a sampling plan. So where you take the sample, checkpoint, with the checkpoint, how you define a lot, and how many tests you conduct within this lot. Then you have to have a detailed standardized procedure on how to perform the measurements. Then you have to establish conformity rules of the type pass or not pass to decide whether the lot is in compliance with the specified limiting value. Then you have to elaborate a statistical analysis to demonstrate that the compliance criteria you are proposing is efficient in discriminating good and bad quality lots. And finally, this is not in the Swiss standard, is establish a system of penalties if the lot does not reach the specified quality. Eventually, some bonuses if it exceeds the quality significantly. And finally, I will show how this Swiss standard accidentally, because this procedure was established in a document that was produced before this ACI document was published. So by chance, or because the criterion used was similar, fit quite well into this frame. Well, this is all I wanted to share with you. There are some references for those who want to have more insight into the topic. Thank you very much, and I apologize for the way, the conditions at which I had to give my speech. Thank you very much, Carmen, for inviting me.
Yeah, thank you, Roberto, for your effort to participate, because it's important to have the opinion of all that have a long track on this about indicators. I think that for you, there is one from Kefe Lee that is there, Roberto. Do you believe we can build up a set of in situ test indicators to determine the actual service life of concrete structures or structural concretes? You can see in the Q&A.
Yes, if I understand, you can build up a set of in situ test indicators to determine the actual service life. Well, I think in this case, when we want to associate the indicators with service life, we need to have some sort of modeling, as in which you associate the indicators directly. The model can have the indicators as input parameters, or the parameters of the model can be estimated from the indicator. For example, you can, I showed some correlations, and that this could be, but sometimes, for example, in the Canadian standards, they say that about the Coulomb test, it says that for chlorides, the Coulomb test should not exceed 1,500 coulombs, I think up to 56 or 91 days of age. But then it says that for an extended period of life, service life, then the value should be 1,000. But there are no values associated, because normally, I think in North America, different to Europe, they try not to be specific on numbers, to avoid that lawyers later, if you say it's 50 years is your service life, like happens in the European standard, that if the structure failed at 49 years, then somebody can exert some legal actions. I think this is probably, but I don't know if I answered the question to leak a face. So, but also privately, it will be a pleasure.